These are the answers to the CCEA Factfile for 4.2 Entropy. So question 1, heat is produced when magnesium reacts with sulfuric acid. Then we have the equation magnesium and H2SO4 gives you MgSO4 and H2. So which one of the following is true for the reaction? So the first thing I've done is I've circled heat is produced. So when we're looking at that, that means that the reaction is exothermic. And if it's exothermic, if you think your little graph, we've got the reactants are higher than the product's energy being given out. And that means then that delta H is negative. So B there, delta H is positive, is not correct. A, delta S is negative. Well, we're going from a solid and a solution to a solution and a gas. So that means there's more disorder in the gas or more randomness in the gas. So delta S is positive. So A is not correct. When we look then at delta G, how we work it out, delta G is delta H minus T delta S. If delta H is negative and delta S is positive, then delta G is never going to be positive, so that can't be correct. So it's D, the reaction is feasible at any temperature. So number 2, standard entropy change for the following reaction is plus 138 joules per Kelvin per mole. The reaction is Fe2O3 solid plus 3H2 gas gives you 2Fe solid and 3H2O gas. Standard entropies of the iron oxide, the hydrogen and the iron are 90, 131 and 27 respectively. Which one of the following is the standard entropy of steam? So you can see what I've done is put the values in. We have 90 for the iron oxide, 3 times 131 because there are 3 moles of hydrogen, 227s for the iron, and then the water, I'm calling it X, and there's 3X then for 3 moles of water. We put in then to the equation the entropy change is the total of the products minus the total of the reactants, so 131. 138 is the entropy change, and then the product would be plus 54, and then the total of the reactants minus 438, and we have the 3x then from the water. So 3x is 567, so we divide 567 by 3, you get 189, which is B. Number 3, the decomposition of calcium carbonate is represented by the equation CiCO3 solid gives you CaO, which is solid, and CO2 gas. So delta H is plus 178 and delta S is plus 161. So what's the standard free energy change, delta G, for this reaction at 25 degrees C, which is 298 Kelvin? First thing you need to do is change delta S into kilojoules per Kelvin per mole, and then plug those into the equation. So delta H mine is 178, T 298, and then delta S 0.161, and you get 130, which is B. Number 4, data for the reduction of iron 3 oxide by carbon are shown in the table below. The equation for that reaction, 2Fe2O3 solid plus 3 carbon solid gives you 4 Fe solid and 3 CO2, which is gas. Which one of the following is true for the reaction? Calculate the values of delta H, delta S and delta G for the reaction at 298. So for delta H, we're just looking at the the products. So that's 3 by 393.5, which is negative, and then we have 2 lots of the iron oxide. So total then 467.9 kilojoules per mole. The carbon and the iron don't feature because they're both 0, because they're elements in their standard states. Delta S then, we have 4 times 27.3, that's for the iron. We have 3 times 213.6, that's for the carbon dioxide, so again the reactants. Then take away the products, 2 times 87.4 for the iron oxide, and 3 times 5.7 for the carbon. Plug those all in, you get 558.1 joules per Kelvin per mole. And then working out delta G, which is delta H minus T delta S. You're plugging in your values that you've got, 467.9. Take away 298, which tells you here the temperature 298 upon 0.5581. So having to change that one into kilojoules per Kelvin per mole, and that gives us 301.6. Then, using your results from part 1, explain why this reaction is not feasible at 298 was simply because delta G is positive. Then calculate the temperature above which this reaction would be feasible. So we're taking delta G as 0. So the equation you're using is T equals delta H over delta S. We've got delta H 467.9, delta H 0.5881, so the temperature is 838.4 Kelvin. Ammonium nitrate decomposes on heating to form nitrogen monoxide and water. Write an equation for this decomposition. So ammonium nitrate, NH4NO3, nitrogen 1 oxide, so the oxidation state of nitrogen is 1, oxygen is 2, so it has to be N2O, and then to balance it we need 2 moles of water. This reaction is exothermic and has a positive entropy change. Explain why the process is spontaneous at all temperatures. Well, if it's exothermic, that means delta H is negative, and positive entropy change means that is positive. So negative times a negative, because we've got negative delta H there, it's always going to be positive. So that means it's spontaneous because delta G is negative at all temperatures. Because the negative times the positive here times the positive here is always going to be negative. And finally, zinc is manufactured by the reduction of its oxide using carbon. With the equation ZnO, which is a solid, plus carbon, gives you ZnS plus CO gas. So delta H is plus 237, delta S plus 190. We have to plug that into the equation. What's the minimum temperature needed? So T equals delta H over delta S. Delta H 237, delta S we have to convert, so it's 0.190, and the result 1247.4 Kelvin, so 1248. And that's that.